Hey guys, today we're going to talk about histograms. Histograms are just another way of looking at data. Usually, histograms are large data sets with a pretty decent range, but not too giant. Okay, so we have frequency distribution as how many pieces of data are in each interval. So this particular graph has intervals, and the intervals have to be equidistant apart, which means if I have the numbers 1, 2, 3, 4, my next interval has to be 5, 6, 7, 8. And that's one thing that you want to look at when you're looking at these kind of questions is, are the intervals equal distance apart? Okay. So we're going to look at histograms. They're a type of bar graph used to represent numerical data that has been organized into equal intervals. So notice the picture. It's not a regular bar graph. All my little bars are touching each other. If there's any space between the bars, it's not a histogram anymore, okay? It is just a bar graph. All right, so let's look at the steps. First, we get a set of data. We're going to make a frequency table. Look at the intervals. It goes from 100 to 149, 150 to 199, 200 to 249, and so forth. So as you can see, those intervals are at the bottom of the frequency table, or that's the frequencies on the histogram. And then they just create a histogram graph. When you're creating one, you want to make sure that you don't color so hard that you can't tell the difference between the bars. Notice how you can tell the difference between each of the bars. So when you need to, go back to these steps and you'll be able to see how to create your histogram on your ticket out. Okay. So Toby was doing a project over wind speed in selected U.S. cities. He placed the data below and needed help making a histogram. Help Toby create a histogram with his data. Now, I'll be honest, the hardest part of histograms is deciding the intervals of your frequency table. So if you create a frequency table from data, you always want to list your data from least to greatest. Fortunately, he was already given a frequency table, so he got lucky, okay? So let's look. So look how the histogram is. So it goes between the two values up to where it is. What I did is I went up to 5, because it says 5, and I drew a line down. Then I went up to 10 here, and I drew a line down. I drew all my right lines first, and then shaded as I went and created the lines I needed to. Okay, and I shaded them one at a time because if I didn't, I could easily mistake this one for this one if I had drawn that line already. All right, the histogram shown on the table below shows the number of swimmers of different age groups who participated in a swimming competition. So this is a group of data, and it shows the ages of them. Can we tell how many swimmers there are? Well, sure we can. Because of the bars and their height, I can tell, where is my mouse? There it is. I can tell how many swimmers there are in each of the ranges, okay? But can I tell if there's a swimmer that's exactly 22 years old? No, I can't. I can tell that there's 5 somewhere between the age of 20 and 24. That's the thing with histograms. We have no specific values. Okay, I do know that I don't have any under 19, and I do know that I don't have any over 60. So let's look at how Miss Garcia interpreted this particular histogram. I'm trying to see. Okay, so I did nothing to the graph until I started reading the which statement is true. So I said there were 15 swimmers who were younger than 30 years old, okay? So I looked at 30, and younger is these two columns. 10 plus 5 is 15. That one is true. But remember, in case I make a mistake, I've got to go through all of them. So B says a total of 10 swimmers were 50 years old or older. So this says 50, and look how I did 50 or older. There's 12 of them, so that's false. And then the number of swimmers who were 40 years old or older is less than the number of swimmers who were 29 years old or younger. So see how I put that mark there? And so I took the 5, 10, 20, and 10, and I added them up. Okay. I think that is 5, 10, 20, and 10 is 45. And the 14, 4, 4, and 8 are over here, and that's 29. So that's false because it says the number of swimmers who were 40 years old or older is less than the number of swimmers who are 20 years. Okay. And the next one says a total of 70 swimmers participated in the competition. So I just took one more step, and there's 74, so that's wrong. And so A is the correct answer. Remember to pause the video if you need to fill in your notes. Make sure you have them printed out. All right. So let's see. The BMS coach lists the number of points scored in each basketball game. The score listed below is used the scores to create a frequency table in the histogram. So as you can see, my scores are just listed because that's what a coach would do. They'd go game, and so forth and so on. And they wouldn't be from least to greatest, okay? So watch how we do this one. I list them from least to greatest. Notice I've got check marks. I count and make sure I caught them all. And then I looked at my data. I said my range was 32, and I thought, they give me 4 spots on my frequency table, right? 32 is close to 40. Yeah, it's close because I don't want to have my intervals to be like 10 to 14, 14 to 18 because that's hard to count, okay? If you can do 5s or 10s in your intervals, that's really nice. And so with a range of 32, I divided it by 4 and got 8, and I rounded it up to 10. Can you see that? Here we go. I'm going to skip count by 10s. Since my lowest number is 16, I need to start at 10. So I filled out my table 10, 20, 30, 40. And then I know that 1 less than 20 is 19, 1 less than 30 is 29, 1 less than 40 is 39, and that these all have to have 9s in there, okay? Now that may not seem like it's 10 numbers, but it truly is because histograms are different than counting. We've got 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So because 10 is included, it's actually 10 values. So just like when I'm creating a fraction bar, I put a slit down the middle of my histogram graph, and then one over here and one over here, and then I just graphed it like I did that first one. Make your paper look like mine. Oh, sorry. I'm sorry, I skipped a step. When I come over here to the 10 to 19, I look at my graph and I'm like, 16, 18, those are less than 19. Check, check. 20 to 29, I go 1, 2, 3. And that's where I got the 3 from. 30 to 39, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, that's how I did that. See how important it is to have them listed from least to greatest? It just makes your life so much easier when you're trying to fill in your tally chart. All right. A choir director made a histogram showing the age of the members in choir. Okay, so it says, which statement about the data of the histogram must be true? So the first statement says more than half of the members are from 46 to 73 years old. So look, 46 to 73, I totaled them up to 50. And then younger is also 50. They're equal. So that's not right. It says more than half, not half. Ooh, I did not mean to do that. Let's backspace. Hey, go back one. Ooh, I touched the mouse. All right. B says there are more men than women in a choir. Okay. We have no idea whether they're men or women. None of this says men are in gray and women are in blue or something like that. It all just says members of the choir. So that's why I put no idea. And they will do that to you. This is a star question. Okay. Okay. The choir has a total of 100 members. Well, we already found out what half was and half was, so 50 plus 50 is 100. So that's the right answer. Let's prove this one wrong. Exactly 20 members are less than 32 years old. Well, 32 is here, and 20 plus 15 is not equal to 20, right? I did it again. Darn it. All right. So you have a ticket out of histograms and you've got to create your own. So do your best. I'm proud of you.